Hello, this is Jay Gandhi, and this is my lab report for AE 2610 digital sampling. My experiment measures like the distance effect on the PSD. So it's easy to observe that the power decreases as you move away from a source of the frequency. But what trend does it follow, and how does this trend is this trend different for different frequencies? So the power spectral density generated by the DAC system identifies the power distribution from a range of frequencies. It records peak frequencies and their corresponding power. And in this lab, we're going to use it to identify the effects of different distances in power. So, why is this experiment important? So, the phenomenon of distance reduction is used in noise control and seismology. It's used for predicting the spread of sound and how a seismic wave dies out. So we're going to use the DAC software and the system with the microphone connection. We're going to use the online tone generator that's set to 80% volume, and it will produce these frequencies. A tape measure is used for distances, and then um, the software is set to its default conditions over here. And then plus the high pass filter is used to block out any background noise. My computer speakers are set to 80% volume. So this is my setup, and we're gonna start by playing like a 750 hertz frequency. We're gonna position the microphone at 1 centimeter. We're gonna save the data to CVS files using the software, and repeat the procedure for 5, 10, and 15 centimeters. We're gonna repeat the above for the remaining frequencies. Data reduction is done in MATLAB, and results. Okay, so I'm not gonna go too much into the track data. It just shows like a range or like a large variety of waveforms, and the peak frequency is recorded with along with other smaller peaks. And so mic validation. Basically, all this is saying is that for low frequencies, the microphone does not capture the PSD very well. It's like around 3%. For mid-range frequencies, it does a pretty good job, and then for higher frequencies, it does an all right job. And here's my experimental results. So for all frequencies captured, the trend is generally like easy to notice that like the closer you are to the speaker, the larger the PSD is, and it's like the same for almost every or all of the frequencies we recorded. And this graph just shows the peak PSD like versus distance. So it's not a linear trend, which is easy to identify. It's a 1 over R relationship where R is the distance away from the speaker. And then uh, for mid range frequencies, there's higher peaks. So 1250 hertz has a higher PSD than 5000 hertz. Success criteria. So um, we're going to properly record the data with little background noise and make sure that the microphone is properly placed and stationary during recording time. And we're going to make sure that like the PSD for his frequency plots show a peak frequency at the expected value based on the tone generator, and that there's a decrease in power and peak power density over distance, because that's what's expected. And the trend is generally consistent and doesn't break too much. It shouldn't be increasing, you know. Um, so complications and mitigation. Background noise can occur at low frequencies, so the easiest solution is just to use a high pass filter at 200 hertz. Um, and then we're also going to perform the experiment in a quiet setting. So the microphone doesn't capture PSD well for low frequencies as seen in table 2. So we're just going to make sure that everything's above like 700 just to be safe. And some echoing is observed in my graphs. You can see them in figure 2 and 3. And the solution to that is just like keep the setup away from walls to mitigate that. And conclusion. So multiple frequencies show the same decay trend for low, mid-range, and high frequencies. So the trend is not dependent on frequencies, and the experiment shows that a strong relationship of distance decay on power density is apparent, and this is important to consider in fields like acoustics and seismology. So power density is higher for mid-range frequencies, as you can see like on this table. So what is like why is that occurring? So computer hardware like MacBook speakers emphasize mid-range frequencies more than low or high frequencies. That explains why the 5000 hertz frequency produces a lower PSD peak than the 1250 hertz at every distance. That was my lab. Hope you enjoyed.